Hello and welcome to Grace tutorial. In this video lecture, we will be discussing about the part 4 of the acids, bases as well as the salts. If you are the new viewer, I would urge you to watch the first 3 parts of this chapter so that it will be easy for you to understand. Well, let me begin the session commencing the physical properties. Here we are going to discuss both the physical as well as the chemical properties of the bases. First of all, let us discuss about the physical properties. The first physical property that we have, they have a sharp and bitter taste. If you look at the taste of the base, the taste is bitter taste in nature. This is what we need to remember. That means they have a sharp and bitter taste. The base can be identified or the base can be recognized by the bitter taste. Point number 2, they change the color of the indicators. Let us have a look at some of the indicators. Well, we have the various indicators like the litmus indicator, methyl orange indicators, phenolphthalein indicators, etc. What happens when a red litmus changes to the blue color? Then that substance is basically said to be as a base. That means in case of a base, the red litmus will be changed to blue. If you look at the indicator of this methyl orange, what happens? The orange will be turned to yellow in color if the substance is basic. Similarly, we have phenolphthalein, and this phenolphthalein it's colorless. The colorless will be turned to the pink color if the substance is base. In this way, a substance is said to be as a base if its color changes on the basis of its various indicators. That means if the red litmus changes to blue, then that is said to be a base, and if the orange will be turned to a yellow substance, then that is said to be a base. Similarly, if the colorless substance using the indicator, if it is changed to the pink color, then that substance is regarded to be as a base. So this is what they change the color of the indicators. That means the bases generally change the color of the indicators in this way, and we need to understand. Well, there are some of the bases which do not affect the indicators. But which are the bases do not affect the indicators? The bases which are insoluble. That means the bases which are not soluble, they do not affect the indicators. We have third point, that is they are soapy substance. In the beginning of the chapter, we had discussed that the bases can be recognized or the bases can be identified on the basis of their soapy touch and by the bitter taste. Well, the bitter taste is the point we had discussed. Similarly, the bases are soapy in nature. That means the soapy substances, that is, they are slippery to touch. Similarly, we have another point of the physical property, that is they show a mild corrosive action. That means slightly it burns on the skin. Similarly, we have one more point, that is they are strong electrolytes. The bases are generally strong electrolytes. So these are the various points of the physical properties. Now we will discuss the chemical properties of the bases. Well, the first property is strong alkalis absorb carbon dioxide from the air to form carbonates. Well, we have strong alkali, and when the strong alkali reacts with carbon dioxide, these strong alkali absorb the carbon dioxide which is present in the air to form the carbonate along with the water. Let us look at some of the few examples so that it will be easy for you to understand. We have sodium hydroxide. When the sodium hydroxide reacts with carbon dioxide which is present in the air, it forms the sodium carbonate with the water molecule. But now the question is that how the sodium carbonate is obtained from here. We need to understand the point. Well, what happened here? The sodium hydroxide, it absorbed the carbon dioxide which is present in the atmosphere, which is present in the air, to form this sodium carbonate. That means the sodium carbonate comes under the carbonate category, and the water molecule is also obtained from here. Similarly, when this potassium hydroxide KOH. When this potassium hydroxide reacts with carbon dioxide, how the sodium hydroxide absorbs the carbon dioxide to form the sodium carbonate. Similarly, the potassium hydroxide absorbs the carbon dioxide to form the potassium carbonate K2CO3 with the liberation of the water molecule. So that's all about the first one, that is the first chemical property, that is the strong alkalis absorb the carbon dioxide from the air to form the carbonates. Property number 2, they neutralize the acids. So who do that they refer to here? Yes, here they refer to both the bases or alkalis. So they neutralize the acids to form the salt as well as the water. So the bases of the alkali neutralize the acids. They neutralize the following acids to form the salt as well as the water. Let's have a look at some of the few examples so that it will be easy for you to understand. We have calcium hydroxide, which is basically a base. When it reacts with the acid, what happens? The calcium chloride is obtained. But we need to understand that how the calcium chloride is obtained by the combination of these two substances. Let's have a look. If you will dissociate this calcium hydroxide, you will get Ca2 plus and OH. Similarly, if you will dissociate this hydrochloric acid, you will get H plus Cl minus. So the positively charged part of this compound will react with the negatively charged part of this compound. There will be a reaction between the Ca2 plus and Cl minus. In this way, the calcium chloride is obtained and the water molecule is remain. Similarly, we have another base, that is ferrous hydroxide, and when this ferrous hydroxide reacts with hydrochloric acid, it exactly gives the ferrous chloride with the liberation of the water molecule. If you will look at this, how this ferrous chloride is obtained by the reaction of these two, we'll get, if you will dissociate this FeOH2, you will get Fe plus, Fe2 plus OH minus. Similarly, when this ferrous hydroxide reacts with hydrochloric acid means H plus and Cl minus, the positively charged part of this compound will react with the negatively charged part of this compound to form the ferrous chloride, and in this way these two substances are obtained by the reaction of this acid as well as the base. Well, this is what the second chemical property of the bases. Now we will discuss the third chemical property of the bases. Well, the third chemical property says that when the base or alkali reacted with the metallic salt, what happens? They precipitate as these substances. That means they precipitate as insoluble metallic hydroxides. The insoluble metallic hydroxides are obtained and they are the precipitates. That means the base or alkali reacts with the metallic salt to form the salt along with the insoluble hydroxides, and these are the precipitates. Basically, these reactions come under the category of the double decomposition, double displacement reaction. For example, let us see some of the few examples so that it will be easy for you to understand. We have copper sulfate. When the aqueous solution of the copper sulfate reacts with the aqueous solution of the ammonium hydroxide, that is NH4OH, we get the aqueous solution of the ammonium sulfate with the precipitation of the copper hydroxide, which is a pale blue in color, and this is an insoluble hydroxide which is a precipitate and its color is pale blue, and this insoluble hydroxide is obtained when the metallic salt reacted with the base like ammonium hydroxide. Let us see that how this product is obtained by the reaction of these two substances. We have copper sulfate. If you will dissociate this copper sulfate, you will get Cu2 plus and SO4 2 minus. Similarly, if you will dissociate this ammonium hydroxide, that is NH4OH, you will get NH4 plus OH minus. So you already know that the positively charged part of this compound will react with the negatively charged part of this compound. That means the Cu2 plus will react with the OH minus ion to form the CuOH whole 2, that is a precipitate which is pale blue in color. Similarly, the ammonium sulfate is obtained here. So we have one more example, that is the zinc sulfate. When the zinc sulfate, if you will dissociate the zinc sulfate, then what happens? The Zn2 plus and SO4 2 minus will be obtained. Similarly, this sodium hydroxide, whenever you will dissociate, you will get Na plus and OH minus. That means the positively charged part of this compound will react with the negatively charged part of this compound to form the zinc hydroxide, which is a gelatinous white in color, and it is a precipitate, that is the insoluble hydroxide. Similarly, we have one more example of this reaction, that is the ferrous sulfate. When the ferrous sulfate reacts with the sodium hydroxide, the Fe2 plus and SO4 2 minus, if you will dissociate these two, you will get Na plus and OH minus. So the positively charged part of this compound will react with the negatively charged part of this compound, and it forms sodium sulfate along with the ferrous hydroxide, which is a dirty green in color. That means when a base or alkali, what do you understand from this reaction? When a base or alkali reacts with a metallic salt, the salt is obtained, but along with that the insoluble hydroxide, which is in the form of the precipitates, are obtained here. That's what all we need to understand from this reaction. Now let us move on to the fourth chemical properties of the bases. Well, this property says when the alkali reacts with ammonium salt, it gives the salt with the water as well as the ammonia. Let us look at some of the few examples so that it will be easy for you to understand. We have ammonium chloride. Ammonium chloride is basically an ammonium salt, and when it reacts with alkali like sodium hydroxide, the salt, that is the sodium chloride, is obtained with water molecule along with the ammonia gas. Well, this ammonium chloride, if you will dissociate this ammonium chloride, you will get NH4 plus Cl minus. Similarly, if you will dissociate this NaOH, that is sodium hydroxide, that is Na plus and OH minus. So if you will combine in some way that the positive part of this compound, that is NH4 plus, reacts with the negative part of this compound, that is OH minus, so there will be a chance of the formation of the ammonium hydroxide. But here the ammonium hydroxide is not the product. What's the product? The product is the sodium chloride is obtained. That means the positively charged part of this compound will react with the negatively charged part of this compound, and in this way the sodium chloride is obtained. But there is an evolution of the ammonia gas as well with the water molecule. Similarly, if you will take the two molecules, the two ammonium chloride, ammonium salt, react with this calcium hydroxide, what happens? The positively charged part of this calcium from this calcium hydroxide reacts with the negatively charged part of this ammonium chloride, that is chloride, to form the calcium chloride, and water molecule is obtained along with the evolution of the ammonia gas. And here you need to understand that the ammonia gas is obtained here. So similarly, we have ammonium sulfate, that is NH4 whole 2 SO4. When this ammonium sulfate reacts with KOH, the positively charged part of this potassium reacts with the negatively charged part of this ammonium sulfate, that is SO4 2 minus. It reacts with K plus and SO4 2 minus. They react together to give the K2SO4, that is potassium sulfate, which is basically a salt, with the water molecule along with the evolution of the ammonia gas. In this way these products are obtained. That means when the alkali reacts with the ammonium salt, then it gives a salt with water along with the ammonia gas. That means the ammonia gas is liberated from all of these reactions. Well, that's all about the fourth chemical property of the bases. Now we will discuss some of the general uses of the bases. Well, we have the various bases such as sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide, aluminum hydroxide, ammonium hydroxide, and calcium oxide. When these bases are used in the different ways. For example, we have sodium hydroxide. Well, the sodium hydroxide, that is NaOH, is used as the manufacturer of soap. That means while in the manufacture of the soap, the sodium hydroxide plays a very important role and the key role for the manufacture of the soap. That's the use of the sodium hydroxide. Well, if you look at the use of the potassium hydroxide, here the potassium hydroxide, that is KOH, is also used to the manufacture of the salts and soaps and it is also used in the batteries as well. Similarly, we have calcium hydroxide, that is CaOH2. When the calcium hydroxide, that is CaOH2, if you look at the use of this calcium hydroxide, it is also used in the manufacture of the bleaching powder. Similarly, we have another use of the magnesium hydroxide. The magnesium hydroxide, what's the formula for magnesium hydroxide? The formula for magnesium hydroxide is MgOH2. When this magnesium hydroxide is used as an antacid, it works against the acid and it is used as an antacid. Similarly, we have another base, that is aluminum hydroxide. The base aluminum hydroxide is used as a forming agent basically in the fire extinguisher. In the fire extinguisher, this is used as a forming agent. So, which is that base used in the fire extinguisher as a forming base? Means that you need to say that aluminum hydroxide, that is AlOH3. Similarly, we have ammonium hydroxide, that is NH4OH. This ammonium hydroxide is used to remove the grease stains if it is attached to any cloths. That means to remove the grease stains from the clothes, this ammonium hydroxide plays a very important role, and it's very efficient to remove the grease from the clothes. Similarly, we have one more base, that is calcium oxide. This calcium oxide here will be used as a drying agent. In this way, the various bases have its various uses, and we need to understand what all those uses. That's why these are the uses, and you need to remember some of the uses of the bases, that's because it's going to come in the examination point of view. Well, that's all about the base and its use, the general uses of the bases. Now we will discuss the pH scale and its importance in everyday life. Well, if we look at the pH scale and its importance, we need to know much more about this. Why? Because it's very important for the examination point of view. Well, first of all, let us try to understand that what is the pH scale. The pH of a solution is the negative logarithm. The pH of a solution is the negative logarithm to the base 10 of the hydrogen ion concentration expressed in moles per liter. So this is the definition of the pH. That is the pH, that is the negative logarithm of the hydrogen ion concentration, which is expressed in moles per liter. That means minus log pH equal to log 10 1 upon H plus, and that also equal to can be written as minus log 10 H plus. So the negative logarithm of the hydrogen ion concentration is what basically called the pH. So what is this pH basically, and who devised this? A Danish chemist. Well, a Danish biochemist and his name is Sorensen in 1909. Well, a Danish biochemist in 1909, his name is Sorensen, devised a scale to represent the hydronium ion concentration in the aqueous solution. That means of the given aqueous solution, to represent the hydronium ion concentration, he represented a scale which is regarded as the pH scale. Basically, here the P is a German word, that means a potenge. That potenge, here it refers to the power. That means pH means the power of hydrogen. So the pH simply means the power of hydrogen, and while writing the pH, you need to remember here that the P should be written as the small and H should be written as the capital. Here the P stands for potenge. It's a German word which means power, and H stands for hydrogen. So the power of hydrogen is what basically stands for pH. So the pH scale represents the hydronium ions of the given aqueous solution. So this is the definition of the pH, the negative logarithm to the base 10 of the hydrogen ion concentration. That is what I have written in the formula wise, that is pH equal to minus log 10 H plus. Well, if you look at the pH scale, the pH scale ranges from 0 to 14, and the pH 7 is basically the neutral, and if the numbers less than 7, that is 6, 5, 4, 3, 2, 1, 0, That means these are acidic in nature. That means the acidic nature increases as it comes below the 7. That is, as it comes from 7 to 6, 5, 4, like this, the acidic nature increases. Similarly, the basic nature increases if it goes after this 7. That means if the numbers from 7 to 14, the basic nature generally increases. That is 8, 9, 10, 11, 12, 13, 14. All these are the basic in nature. So what is the neutral of the pH? The 7 states that the pH is in neutral, and less than 7 we have the acidic nature, and the acidic nature increases, and greater than 7 the basic nature increases. And we need to remember this scale, and this scale is also very much important for the examination point of view. If you will remember the scale, which is the 7 neutral, and after that it increases the alkaline, and below that it increases the acidic nature. Sometimes there may be a question that draw the pH scale, and we need to remember the scale of the pH so that it would be better for you to understand. Now let us have a look at the importance of the pH. Why the pH is very essential to study, and what is the importance of the pH? How is it used in our day-to-day life? We need to understand these points. Well, our body survives well within a narrow range of the pH, that is 7 to 7.8. 7 to 7.8. Within this narrow range of the pH, our body survives. Not only our body, the body of the plants as well as the animals also survive in the narrow pH range. Well, we have another use. It is also used in the agriculture, because the pH of the soil plays a very important role for the growth of the production, for the growth of the crops. For example, we have the rice. The rice generally grows in that pH of the soil which is slightly acidic in nature. That means if the soil is slightly acidic in nature, then the rice grows in that region, and the sugarcane grows in the neutral region. That means the soil where the sugarcane is grown, that soil, the pH of the soil should be the neutral. Similarly, if you will take the citrus fruits like lemon, orange, these fruits can be grown in that soil where the pH is more than 7. That means the pH is alkaline in nature. So if the pH of the soil is alkaline in nature, and in that soil the substances like the citrus fruits are produced, and if the pH soil is slightly acidic in nature, then in that soil the crops like rice can be grown, and in the neutral pH soil the sugarcane is grown. In this way, the pH of the soil plays a very important role in the agricultural field. Similarly, it is also very much used in the medicines as well. And how is it used in the medicine? Well, if you look at this, there are some diseases, and these diseases can be diagnosed on the basis of the pH of the blood and urine. So if you do not know the pH of the blood and urine, it's impossible to diagnose those diseases. That means in order to diagnose those diseases, we need to understand the pH of the blood and urine, so that there will be some of the remedies, there will be some of the solutions to solve the problem. It is also used in the digestive system. Generally what happens, the hydrochloric acid is produced in our stomach in order to digest the food. That means for the digestion of the food, the hydrochloric acid is produced in the stomach. But when it releases the excess of hydrochloric acid, there will be a chance of burning in the stomach. Then one type of irritation will be created in the stomach. Then what happens at that time? If you will have the antacid, the milk of magnesia, whenever you start feeling an irritation, whenever there is an irritation produced in the stomach, what you generally have? You'll have an ENO. That means the ENO is basically the milk of magnesia, which is the antacid. Antacid means anti plus acid. It goes against the acid and it fights against the acid to kill the acid. That means it neutralizes. So antacid, which is the milk of magnesia, is generally a base. That means it is also used in the digestive system. Once again, I will repeat this point, my dear students. How the hydrochloric acid is produced in the stomach to digest the food. But when this hydrochloric acid is released in the excess of amount, then the irritation will be started in your stomach. At that time, if you will have the milk of magnesia, which is an antacid, the antacid is generally a base, and it is used to kill the acid, as to reduce the acidic nature in your stomach. Well, this is also used in preventing the tooth decay. Well, generally you will have a lot of sweets and chocolates, everything like that. All the sweets and the chocolates are degraded by the bacteria which is present in the mouth. At that time, what happens? Generally, the saliva is produced by the salivary gland. But you know, sometimes due to the lack of the saliva produced by the salivary glands, there may not be a chance of killing or preventing the bacteria which is present in the mouth. That's why we need to brush our teeth twice a day, so that it would be better for you, for your safe teeth, and so that you can have everything in the future as well. That means whatever the toothpaste that you are using, the toothpaste consists of the salt. That means the salt is basically a paste. It is alkaline in nature. That means the pH is also very much important, and it is useful in preventing the tooth decay. In this way, we have the various importance of the pH in our day-to-day life. But here I have mentioned some of the few examples that in what cases, in where the pH is very much important and the pH is generally used, and that's what I have explained you in the 5 points that is the importance of the pH. And there are many of the importances. But now we have discussed only the 5 importances. And if you are asked, right, what is pH, and explain the pH scale along with the importance of the pH in everyday life, that you need to explain the scale of the pH, and you need to remember all this. Similarly, you need to remember the importance of the pH in our day-to-day life. Well, that's all about the importance of the pH and the pH scale. Well, this is what we have completed about the base portion. So this is the part 4 of the acid, bases as well as the salt. And here in this portion, we have completed the entire things about the base. That is, we had done, you know, the methods of preparations of the bases and the physical properties, chemical properties, and its various importances, like importances of the pH in our day-to-day life, along with the pH scale, the definition of the pH, and the pH is given by whom and when. Everything was explained here in this lecture, and I hope that you liked the video very much. And if you would like to watch the next part of the video, that is, in the next part we are going to discuss about the salt, and if you would like to watch the next part of the video lecture, I would request you to subscribe to our YouTube channel for the latest notification. Thank you very much for watching.